So the last two tasks now would be to get those other two parts solidified so we can print them and shell them out. So let's see what happens if we apply a Solidify modifier. And sorry, I said apply, but what I mean is to add a modifier again, because in this video I'm going to point out one of the major problems of shelling out a design, and that's a problem in Blender, that's a problem in Alias, it's probably a problem in most programs anyway, because you will see soon what I'm going to talk about. So let me go to here. Let me zoom in. And nope, there we don't see it. Let me actually try to show the piece here. Oh yeah, there we see it. You see this? So the Solidify modifier, the way how it's working right now, you see the offset is -1, which means, for example, we shell it to the inside. Of course, when you design the outside surface and you add a thickness, you don't want your object to grow to the outside. You want it to grow to the inside. That's the reason why I'm using a -1 for the offset. However, the problem is those flat surfaces, they can be offset quite nicely, not a big deal. But here we have a concave surface or surface flow, and that results basically into this problem here. If maybe we only offset this by a millimeter, chances are high that it's not overlapping yet. See, for example, there. So that's just the radius is too small that when we offset it by 3, that it's not going to overlap. So the problem we're going to face here is also this is not really good geometry. If we send this to the printer, the 3D printer will tell you that there are self-intersecting surfaces and cavities, and the printer is going to strike. So what we have to do is actually we have to construct this inner surface by ourselves. And hold on, let me also bring that Solidify modifier back, because you see everything is nicely cut, but right here the surface actually, that bottom part shouldn't be there. We should be able to see through it. And whenever you use like a Solidify modifier together with Boolean operations and you get something like this, chances are high that the polygon mesh the Solidify modifier generates simply is garbage. And that is what's confusing the Boolean operations, specifically the last one. I think the first one to a certain degree will work normal, yeah, but then the second one, that one's a little bit cranky. Okay, so having said all this, now I'm going to, for good, remove the Solidify modifier. And you also notice that Blender right now, because of all the Boolean operations, is a little bit slow. So what I'm going to do is first, I'm going to select all my objects and turn those off. Select this one, turn those modifiers off. So Blender doesn't have to recalculate those non-stop. Okay, good. And then let's select this one, just turn this one off, turn this one off, this one, and the last one. Okay. So if I click apply, Blender will tell you the modifier cannot be applied because the modifier is applied to an object that uses a multi-user data. Multi-user data, what that means is all these objects actually use this mesh, because the modifier is creating additional mesh geometry, and the modifiers actually are applied to the object, so it would change the geometry. And because it's not a single mesh, the mesh is shared, it doesn't allow you to bake the modifier so that we have the shell for all the other objects as well. But that's not really a big problem. So let's see, iron top. Okay, so that's the one I would like to work with. Bottom and midsection I remove. I hide them. So I click and remove my Solidify modifier. So then I make sure I have my 3D cursor set, turn my screencast on. Then I go into edit mode, select all my mesh, and I'm in metric, okay. Then I press T, so I have my property panels, spacebar, and then type in Solidify. You see, you have the modifier Solidify, which is interactive, and you can also offset a surface or solidify inside mesh editing through a mesh command. So I select it, and then 3 millimeters, this is symmetric, is 1 meter, 10 centimeters, 1 centimeter, millimeters. So 3 millimeters would be 0.003. And there we see now I have this mesh created. Doesn't look too bad. There's one problem, however, with it, and I would like to show you what to watch out for. So here I have my midsection, and let's turn those on, and you see, wow, all those Boolean modifiers now go crazy. So let me go into edit mode, and let's take a look what this offset actually did. So you see, the offset basically, or the Solidify, generated a thickness, but at the same time you can see we have some faces also along the mirror axis. Now some of these faces by hand I have to remove. So for example, this one and this one. Those which I have highlighted I would like to remove because the mirror modifier is adding the other half, so I cannot have those faces inside. So I just remove faces. Let's leave edit mode, and yeah, something else doesn't work, and even says the Boolean operation cannot be operated. Is that maybe because of the difference or something? Yeah, see, all that stuff doesn't really do anything. We get some interesting results. And here is actually the reason why. You see, it clearly looks like something is overlapping. It's over the mirror axis. Now if I go into edit mode, I actually can see that the offset that I created inside overlaps. So that's the reason why I snapped my 3D cursor to the object center. I set my 3D pivot point to 3D cursor, select all those points that define the cross section, and then simply scale along the x-axis to 0. So now they're all straight. And let's leave edit mode, and voila! You see? Everything works. Perfect. The only problem I have left is there are still those overlapping geometry parts. Now, the outside of your product is really important. The inside surface is less important. And if you open a remote control at home for TV, for example, you will see that those those inner surfaces are not perfect offsets of the outside. So for example, this edge we can change or sharpen, and specifically because we here are not making a manufacturing model, but just trying to get this piece printed for our own design validation process. I can try to see maybe if I can select a loop cut, and then I start removing those loops. So I'm simplifying actually my mesh. Let's see what I have here. For example, this one I would like to remove, and maybe where does this one go to? Remove, okay. There's another piece like this one. This one I'm going to simplify, and maybe this loop. No, this one I shouldn't remove, but probably maybe this one I should remove. Okay. So let's see what I have, and yeah, this piece does not look too bad. Let me see if actually for a moment just cannot just only remove this part. And remove. Yeah, this is better. Oh, here I have a triangle, not a big deal. Remove the edge, opposite, opposite, and fill. Perfect. Now you see I have, well, I maintain nice and clean loop cuts. So if I, for example, leave the edit mode, yeah, this is good. Just to sharpen this edge down here, I'm going to add another loop cut. So you see this cut is better. Put in my mirror. Show me the Boolean. The top part cuts out nicely. The bottom part cuts out nicely. Let's maybe make a cross-section look. See, no overlapping geometry anywhere. So this is actually really nice. So beginning of this whole Boolean stuff, 3 movies back, I introduced you to make linked duplicates. So we have one shared mesh, because the nice thing about this approach is this mesh modeling I did for this object, I don't have to redo now for my other parts because they all share the same mesh input. So if I press Alt H, I could maybe select the bottom part, okay, and turn the Boolean operations on. In an ideal situation, I should end up just with that piece. And as you can see, I do. And here, I can just turn back on all my different modifiers for the top part. And let's make a cross-section look and take a closer peek. And yeah, you see, everything fits perfectly. I have all my different shells. They all have a correct material thickness. And again, because I am using cloned objects and they're using the same mesh input, the surfacing offset task I did in the mesh for one object will be shared among the other objects. So I saved myself a lot of manual labor work. And this model, for example, right now is pretty much ready to be sent to the printer in case, of course, you would like this piece to be printed in those 3 separated parts. And yeah, so this basically should then end everything about how to use Boolean modifiers and how to create a material thickness to print. To send this actually now to a printer, all you would have to do is go File, Export, and then select Export STL. And there's a little bit more to it. There's another plugin which I will introduce when we actually go to the 3D printer, and I will make one last video just for the STL export.